So I picked this thing up on eBay quite a long time ago. It's just been sat waiting to be played with for a while. It's just listed as a Astrium solid state gyroscope. Now I was sort of kind of hoping it might be a ring laser gyro or something really interesting, but it wasn't that expensive, so I sort of thought, what the hell, let's take a look at it. Now, it actually had a fairly big chunk of lead on the back side. I'm guessing this was designed to be a drop-in replacement for a mechanical gyro, so they added some lead just to make the original gyro mounting dynamics be equivalent. And looking inside, I suspect this might be a bit of a prototype or testing, because there's quite a lot of bodge wires and so on there. So that may also be the case. They sort of did this as a trial to test against performance against the conventional gyro. Now inside, just a couple of boards in here. I've taken a few bits off already. There's a power supply board on the top that's run from the standard aircraft 115 volt 400 hertz power supply, and there's a board down the side with a processor on it. But just the way it's put together, there's sort of a couple of bodge wires there. The sort of ribbon cable is just sort of soldered directly onto the board. Sort of suggests to me this has probably been sort of put together out of some existing kit, or it's a prototype or something. It certainly doesn't look anywhere near sort of aircraft quality construction. And there's just a connector on the board that just goes to the ribbon cable. Again, that's just using IDC ribbon cable doesn't really look very aircraft spec to me. And there were 3 of these modules. I've already taken one out to take it apart. Single axis VSG, which turns out to stand for Vibrating Structure Gyroscope. So these are actual gyro modules, and so there's another one which is mounted here, so you've got the 3 different axes at 90 degrees to each other. And on this board there's these analog devices, 4-quadrant multiply divider chips, and some sort of transformers. My guess is this is possibly interfacing to the output from the original gyro, which may well have been a something like a synchro resolver. So these are maybe producing motion signals that are emulating the signals coming out of the original gyro. Can't think why else you'd need something like that. So yeah, in fact also here we've got a ICL 8038 signal generator, so this is probably generating a sine wave, and then these multipliers are generating the the phase relationship between the drive and the output of a synchro resolver. So this is actually producing a sort of phase output, like the resolvers we've seen in some of the other gyro teardowns have done. And nothing particularly interesting. This looks like a fairly general purpose sort of processor board. There's a 68 HC11 there, couple of analog interface chips, and a big bunch of passive. So I'm guessing this is probably a sort of general purpose analog input output type board. There's some op amps up here, and the way this has all been put together seems to be a little bit haphazard. Also there's another couple of layers of lead sheet under here. But it sort of seems to be a fairly random sort of collection of different types of screw and sort of hand-drawn markings. So looks like something's been dremeled there to get the cover on. So very much looks like some sort of prototype. Now fortunately, because this thing had the power supply, it was quite easy to hook up and get these running. Fairly simple interface, just sort of power and ground. It gives you an analog voltage out, but it seems pretty sensitive. Let's crank that up a bit. Literally just the tiniest movement produces quite a big output, so it's got quite good sensitivity. These cans come apart quite easily. The top seems to be basically just taped on. So we've got a top board with just below there's a few bits of 4000 series CMOS and a bunch of op amps. I've already unsoldered this assembly to get it apart, but so you do have to unsolder this to get this top board off. Then there's a second board in here, which again there's an op amp there, a few bits of voltage regulation, and a voltage reference here, analog devices Ref02. And again, another bit of unsoldering. We've actually got the magic piece in here. This actually held in this cavity with a gasket to keep dust and gunk out. What we have here is this rather interesting looking little beastie. So this is a sort of piezo ceramic material with various electrodes printed on it with probably silver ink and then wire bonded on. So the general principle of this is it sets up a vibration, a very specific vibration mode in this ceramic, and then senses any changes as the thing gets rotated. It changes the way that the vibration propagates around the ring and produces a signal output. But obviously this is potentially a lot more robust than a rotating mass type gyroscope, and I believe the sort of MEMS ones you see these days work on a fairly similar principle, and the various sort of single chip gyros that everyone's using in quadcopters and so on. And in fact, because there's a patent number on there, you can actually get some information on it from that. And here's the patent from 1985, and we can see basically the same thing. We've got an oscillator and gain control system so that it's producing a stabilised signal, and then some sensing to actually detect the mechanical effects. This thing is really very sensitive. Just set it up just sitting on the bench, but literally if I just sort of bend the bench, just put a bit of pressure on the bench, you can actually see quite a clear signal from that if I just bend it. Just tap on it, which produces a fairly massive signal. But so I've no idea. I've never really used any of the MEMS gyros. I don't know how this compares. But also, if it's designed for aircraft use, it's going to be pretty sensitive. Interesting that I think there might be some sort of sampling artifact there, because if I sort of a sudden change does seem to produce a slight sort of sinusoidal output, but I'm sure that will probably average out to the actual amount of change. But so it's just sort of generally touching it there. It does seem to be extremely sensitive. So interesting little bit of obscure tech there. So I've no idea how these compare with modern MEMS gyros, but they're a bit on the big and heavy side to stick on a quadcopter. Haven't got any real use for them, so I'll be recycling these back onto eBay. And if you're interested, just do a search for VSG gyro, and maybe you can have a play with them.